Hello, welcome back to the MLSC YouTube page. We are going to be going over Exam 3 review for Math 1813 or Prep for Calc. So let's just hop right into it. So from section 6C.1 angles, number 1 says find the radian measure of negative 100 degrees. Give an exact answer. So if we remember from class, if we're trying to go from degrees to radians, we're going to multiply by pi over 180, right? If we're going from radians to degrees, we're going to multiply by 180 over pi. All right, so if we have degrees and we're trying to go to radians, we already know we're going to multiply by this right here. So let's go ahead and do that. So right here, it would be negative 100 degrees times our pi over 180. And the reason for this is because these degrees end up canceling. And then you'll be left with negative 100 pi over 180, which reduces down to negative 5 pi over 9. And when it says give an exact answer, just leave the pi like that. Alrighty, number 2. Find the degree measure of 5.9 radians round to the nearest degree. So we want to use this one this time. So we have 5.9 radians. And if we were trying to go to degrees, we'll multiply by 180 over pi. And pi is essentially in this radian unit. So these two units cancel and you're left with just degrees, which ends up being 338.04509 and so on. And it says round to the nearest degree, so that'll be 338 degrees. Alrighty, so number 3 says find an angle between 0 degrees and 360 degrees that is coterminal with negative 900. So if we remember what coterminal means, it means coterminal means that the angles end in the same spot. So essentially, if I were to draw like the graph, right? And we have the angle of 180 degrees, right? It ends on this line, right? It ends here. Now, say we have an angle of negative 180 degrees. Also ends here. So negative 180 and positive 180 are coterminal of each other. Similarly, if we have something like 90 degrees, it ends here. And if we have something like negative 270 degrees, it ends right here. Those two are coterminal. Right, so with this example, we are given the angle negative 900, and we're trying to find its coterminal angle between 0 and 360. So the key is basically to add 360 until you get to the point you want to get to. So if we add negative 900 plus 360, that is negative 540 degrees. So we're still not in our range. So we go ahead and add 360 degrees here. And that'll be negative 180 degrees. Still not in our range, so we add another 360. And we end up with a positive 180 degrees, which is in the range that we wanted. So that is our answer, which means that negative 900, 180 end in the same spot. Alrighty, next one says, so it's on the same number, but it's the second part. Find an angle between 0 and 2 pi. Radians is coterminal with negative 9 pi over 7. So if we remember, 0 to 2 pi is the same as this 0 to 360. So again, we have 9 pi over 7 If in degrees we add 360, in radians we just add 2 pi. So I'm going to go ahead and give this a 7 over 7 to make it common denominators. And I'd be left with 9 pi over 7 plus 14 pi over 7. So that gives me negative 5 pi over 7. So it doesn't quite fit into our range yet. Or actually, my bad. That's actually a positive 5 pi over 7. Which does fit in a range. So that is our answer. Alrighty, for the next one it says, find the central angle theta in both degrees and radians if the radius of the circle is 21.8 centimeters and the arc length is 42 centimeters. Okay, so essentially we have some circle, okay, and on this circle we know the radius is 21.8 centimeters, and we have some angle, theta, and we know some arc length, 42 centimeters. So this is probably not drawn to scale at all, but this is the idea, right? And if we remember, S equals R theta. So if we know our arc length is 42 centimeters, and we know our radius is 21.8 centimeters, we can find our theta. So this will give us theta in radians, but we know from problem 1 and 2 how to change it into degrees, and it wants it both in degrees and radians. So if we do that math right there, we end up getting, divide by 21.8, we end up getting theta is roughly 1.9 radians. Awesome. So now if we want to change it to degrees, if we remember from up here, if we go from radians to degrees, we're going to multiply by 180 over pi, which gives us about 110.4 degrees. So our angle wasn't drawn to scale, but we knew the picture was roughly that. Alrighty, so now it says find the radius of the circle if the area of a sector with central angle 21.5 degrees, 215 degrees, my bad, is 40 inches squared. Alrighty, so we can remember that area of some section on a circle is 1/2 radius squared times theta, and theta here is supposed to be in radians. Okay, so if we know theta in degrees, from what we know, we can multiply by pi over 180 degrees, and we will get some 215 pi over 180 radians. So that's our angle in radians, right? And we know our area is 40 inches squared, right? So if we have 40 inches squared equals 1/2, and we're trying to find the radius, right? So r squared of our theta, which is 215 pi over 180, if we move everything over, r ends up being the square root of 40 times 2, all divided by this 215 over 180 pi, right? Which, just plug that into a calculator, you'll get about 4.6 inches. Alrighty. Okay, now on to number 6. It says, an angle has its vertex centered at the origin of a circle. It cuts an arc length of 54 centimeters and subtends a sector area with 324 centimeters. Find each of the following. So again, area we know is 1/2 r squared theta, and we're talking about arc length, and we know arc length is radius times theta. Both thetas are in radians. Do not forget that. Okay, so we're being asked, what is the radius of the circle, right? So we are going to actually use both formulas for this. So we're going to use a equals 1/2 r squared theta, and we know that 324 centimeters squared is equal to 1/2 r squared theta. So we have two unknowns in this, right? So if we know s is equal to r theta, and we know s is 54 centimeters is equal to r theta, we can find r in terms of theta, or theta in terms of r in this. Okay, so we'll do theta is equal to 54 over r. So now we know theta, we can plug it into here, and r will be our only unknown. So 324 centimeters squared is equal to 1/2 r squared times 54 over r, right? Because this was our theta. And if you notice here, we have r squared over r. If we get rid of that r, and we'll get rid of 1r here. So now we have 324 equals 1/2 r times 54, which ends up being r is equal to 12 centimeters. Alrighty, so the next question says, what is the angle in both radians and degrees? So if you remember from the last one, our theta can be found by doing 54 over r. And we know r now is 54 over 12, so our theta in radians is 4.5 radians. And then if we're trying to change its degrees, we just multiply times 180 degrees over our pi, and we are left with roughly 257.8 degrees. Perfect. Okay, now we'll go ahead and move on to our section 6C.2 and 6C.3, the 6 trig functions. So we learned cosine, sine, tangent, and then the inverses of those, correct? So cotangent, cosecant, and secant. In this one, we're talking only cosine. So if we remember, cosine has to do with the horizontal or x-axis, essentially, right? So let's go ahead and it says, without using the calculator, rank the following in order from smallest to largest. So we have this cosine 12, which will be 12 degrees is probably like right here. So this is 12 degrees. So this is cosine 12. Next one is cosine 85, which is not quite 90, but it is very close to that, so cosine 85. Next is cosine 165, which 180 is here, 90 is here, so 165 is like right about here. Okay, and then cosine 180 is right here. And then cosine 265 is, this is 270, so, right about here is cosine 265, and then the next one is cosine 350, which is right about here. So we're wanting to know from smallest to largest, what is our cosine? So essentially, we're reading off of the x-axis, right, is what I had said. So right here, our x-axis is negative, usually -1, +1, if this is a unit circle, right? So if this is our unit circle, this is -1, this is +1. So if we want our x values from smallest to largest, we'd start here, here, and move our way this way. So right there is cosine 180, which means that that is our smallest. And it's actually -1. The next one that I see is that one, cosine 165. And then we keep going, and the next one I see is this one, which is cosine 265. And then the next one I see is this one, which is cosine 85. So I'm just reading on the x-axis from left to right. So if I keep going this way, the next one will probably be this 12-degree one. So cosine 12. And then lastly, our cosine 350. And again, it says explain your reasoning. The reason for this is because our cosine is typically looked at on the x-axis. So cosine is typically associated with the x-axis, and sine is typically associated with the y-axis. Correct. So if we're trying to rank cosines, we're just trying to rank where it is located on the x-axis. So from left to right, I just kind of read the x's, because left is -1, positive is +1. Left is -1, right side is +1 if it's a unit circle. And so I just read from left to right. All right, number 8 says, assume angle A passes through points A, angle B passes through point B, etc., without using a calculator, rank the values in order from smallest to largest. So angle A is this chunk here, angle B is this chunk here, angle C is this chunk here. You get the vibes, D, E, F. So I'm trying to find smallest to largest of the sines. So if we remember from the previous problem, sine is typically associated with the y-axis. So if we do what we did for the last one, we'll look on the y-axis, and assuming this is a unit circle, this is -1, this is +1. So we're trying to see our y's from smallest, or from, smallest to largest from bottom to top, or from top to bottom, largest to smallest. So if we look at this, our smallest is probably our E, because it's the closest here. So right here is our E. It's the closest to our -1. So that's probably our smallest. So sine E is our smallest. So now we go to the complete opposite side, and these two are very, very close, but A almost looks like it's slightly above. So our largest is sine A. And again, sine I read from bottom to top, or top to bottom, but I read vertically. So now for B, it says find the largest and smallest of the following cosines of these angles. So cosines are the x-axis. And I'll write that here. Cosine is typically associated with the x-axis. And so if we're reading here, our closest there is probably our C. So that means that is our smallest, cosine C. And then if we look at the extreme opposite side, our largest is our F. Just like that.
So for this one, I'm asked to name the quadrant in which -11 pi over 9 lies. So the first thing I want to think about is, remember that to go all the way around one revolution is 2 pi. And so if I go halfway around, that would be pi. And then the other thing to remember is that we're going negative. So we're going to start here with our terminal side, and we're going to go this direction. And so I want to do that for 11 pi over 9 radians. So if I go all the way to here, then that is pi, right? And so I can think about dividing pi into 9 equal pieces. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I guess I have too many. Okay, so I could delete that guy. Oh boy. Let's see. Let's draw that back. Okay, so we have 9 equal pieces, and then I'll go. So I want to do -11 pi over 9. So if I've gone all the way to pi, that's 9 ninths, right? So I want to do 10, 11. So this is 11 pi over 9. And so that would end up being here in the second quadrant. Okay, so second quadrant. Okay, and then it says to find its reference angle. So the reference angle goes from the x-axis to the terminal side of the angle. And so that angle there is going to be 2 of those ninths. So the reference angle is 2 pi over 9. Okay. So for the next one, it says, if sine is positive and cosine is negative, what quadrant does the angle theta lie in? So remember that sine has to do with the y values on the unit circle. So, and then cosine has to do with the x values on the unit circle. So I have positive y values, but negative x values. So that'll be here in quadrant 2. So it'll be positive y values, meaning above the x-axis, but negative x values, meaning to the left of the y-axis. So that would be there in quadrant 2. Number 11 says, find the exact value of each of the following and give reasons. So if I'm looking for tangent of 5 pi over 6, again, remember we're dividing into 6, we're dividing pi into 6 equal pieces. So there are 6 equal pieces. And so 5 pi over 6 will be 1, 2, 3, 4, 5 pi over 6 is right here. Okay, so that's the angle we're looking at. If I think about the reference angle for this, the reference angle is pi over 6. And so my sides of my triangle are going to be 1/2 and negative root 3 over 2 and 1. So that's the triangle that I'm dealing with there. And so we know that the tangent value of 5 pi over 6 is going to equal the y value over the x value. So 1/2 over square root of 3 over 2, and that bottom one is negative. So that's going to give me 1 over square root of 3. So negative 1 over square root of 3 is the answer. Okay. For the next one, I'm looking at cosecant of negative 2 pi over 3. So I want to divide pi into 3 equal parts. So there's a part, there's a part. So I want to do, let me erase that a little bit. I can do that better. There. So I want to do negative 2 pi over 3. So that's 1 pi over 3, 2 pi over 3. So negative 2 pi over 3 is right there. And if I look at that reference triangle, I have a negative 1/2 for the x value and a negative root 3 over 2 for the y value. And so cosecant is equal to 1 over sine of negative 2 pi over 3. Well, the sine value is the y coordinate, so it will be 1 over negative root 3 over 2, which I can write as negative 2 over root 3. Then it says, find the exact values of sine and cosine given that tangent is equal to 5 over 2 and cosine of theta is less than 0. And so I could think about this one and draw a picture. So I know that tangent is positive and cosine is negative. So what that means is that I am down in quadrant 3 because cosine deals with the x coordinate, and then tangent being positive means that sine and cosine have the same signs. So sine and cosine are both negative, so that will be down here in this quadrant. Okay, and so I've got some angle down here in this quadrant. That's where my theta is. And then it says tangent of theta is equal to 5 over 2. So what I can do is think about that as y over x. So again, this one is not scaled to be on the unit circle, but that's okay. We can still compute it. So it's negative 5 over negative 2 is our tangent value, and I can find the hypotenuse. So I can say that, maybe I'll call that r. So I can say r squared is equal to negative 5 squared plus negative 2 squared. And so that gives me r squared is equal to 25 plus 4, which is 29. And so r is equal to the square root of 29. So So r is square root of 29. So now I can find cosine. So cosine is x over r, so negative 2 over square root of 29. And sine is y over r, so negative 5 over square root of 29.